All right, so this is the folder, and basically when I show folks how the system works, since I don't have access to their LMS, I've made this my course menu.htm, and inside there's just the basic launch link that you have to create dynamically using your server, but for right now we've just done it statically. Just to show the course launches. So launch.htm is pointing to this launch.htm right here that I have highlighted. And that is the start of Simple SCORM LMS adapter. That's the frame that holds all the other content. So we pass in there the course ID, which would make sense in your LMS. In this case, we just say a 1 just to pass some value in there. Student name, I just use my name. The name would come from your LMS, the student that's actually taking the course. Student ID is the identifier in your LMS for this person. You may or may not have a student ID, or you may derive the student name from the student ID. So these parameters can be changed inside the adapter in the config file. These are just the standard ones that come with the installation. And then you have the course directory, which is where on your server, relative path, you want us to go to get the course that will be launched when you click the link that is going to say SSLA tryout. Right, so in this case, the course directory is just simply in the course folder. And then in SSLA tryout actually isn't extracted, so this directory doesn't exist. So what you would do is just extract this into extract, just to have a sample course in there. SSLA underscore TRYOUT. All right, so now you have the folder in there, SSLA underscore capital T for tryout. And here it's lowercase t, so we'll just change it over here once it's unzipped. All right, so now we've got a course to launch. So this launch link opens launch.htm. And so what launch.htm does is just gather the query string variables and check the configuration file, which is inside SCORM player globals. It checks the configuration file to see if you told it to launch it in a frame set or launch it in a pop-up. And so then it passes those query string variables into either the frame set or the pop-up window, wherever you told it to launch the course. We have two options. Basically, index splits off into two different options. Like I said, either you can launch in a frame set or you can launch in a new window. If you launch in a frame set, you're going to run parser frame set. If you launch in a pop-up, you're going to run parser. In the end, parser always drives the experience. The only difference is parser frame set includes parser, whereas parser is just called directly if it's a pop-up window. So we'll go take a look at parser frame set first. In parser frame set, this is one of the changes that we made. Wrote an isEmpty function to check to see if the property of obj, which is the pointer to utils, which gives us all of the functionality that we need for this getString utils instance and all these other things down here. Just check to see if it's there or not, basically. So you can see right here, if it's empty, then we need to do some browser checking and figure out where in the frames it is, because depending on if it's in Chrome or if it's in IE or if it's in Safari, it loads the frames in different orders. So we got to look and see where all your stuff is loaded, so that we can put it, point it to the correct object. So some like the
Okay,
name.
so this is not just pulling error. This is actually you're dealing with the different orders of whether they open the frames.
No, this is dealing with the different orders of how the DOM would be created in different browsers.
Right. Okay. Got it.
Yeah,
Okay.
so like in Explorer, JCA
Mm-hmm.
SCORM parser would be located at parent.jca SCORM parser. But
Right.
in
Okay.
Chrome, you would access it by calling parent.jca frameset.b.jca SCORM parser. So if we just did this
Right.
and excluded all this, then it
Yeah.
would never work in
Right.
anything
Yeah.
except Explorer.
Okay. Got it.
And so
Okay.
the Chrome frame check was also something that we updated because the latest Chrome the latest 3 builds of Chrome had a bug in it of basically how it accesses variables inside of frame sets. So that was one of the reasons for writing this method that does all the checking. So that was one of the changes that was made. But basically the parser frame set just creates a frame set and then puts the parser will end up in here. Parser.htm will end up in here.
Mm-hmm.
And then the blank underscore start.htm is where the course will eventually end up. And then this is where the navigation buttons at the top of the page will end up.
Okay.
So if somebody wants to hide the navigation at the top of the page, like they don't want the next and back buttons, just turn the 40 to a 0,
Mm-hmm.
and then this frame just won't show up.
Okay.
And so then you won't, when you, let me see if I click, it's just going to launch it real quick and show you which frame I'm talking about.
Mm-hmm.
That's fine. We're not connected to a server, so it's just saying that I can't talk to the server. This is the frame that I'm talking about right here, this one up here. So if you wanted to not show that, then you would just change this to a 0 and it won't show the frame, which is right here.
Sure. Okay.
Since some people ask for that, so that may be something that may need to be changed, and they say, how do we get rid of this? And it's very simple, just don't show that frame. Also, you can hide this menu as well, either manually by using the button, or in the config file, you can set show table of contents equals to false. And so if you don't want to have any of this blue stuff, any of this blue kind of framing around your course, then what you can do is set this 40 to 0, which takes out the top part, and then go into the config file and say show TOC or show table of contents equals false, and then it won't. It'll start out looking like that, and there will be no show or hide button.
Okay. Now, in my particular course, I think you remember that also when I'm running, when an event gets shown with something about there's a TOC, and then I do a break there. So,
Right.
okay.
So that's a possible. I mean, all those are different possibilities. I'm just showing like the most, the most general case most people do. So that's parser frame set. That's really all you need to know about that file. So then,
and it includes, or sorry, and parser frame set includes parser. It's basically a superset of parser.
right there you go, right there.
Yeah.
So it says obj frame, which is wherever it figures out JCA SCORM parser frame is at, it puts the parser in there. So JCA SCORM parser is right here. So this path ends up inside of here. But how it gets there is either through this path or directly. It's either through the parent frame or directly. Some browsers you can call it directly, some browsers you have to call it through the parent frame. So that's what this case is for.
Got it.
And then once we get the course loaded, then we set up the navigation so that they can navigate. And if you have that hidden, then it'll get set up so everything else will run, because there's a couple of methods inside of there that may or may not be used by your course. So we don't want to just not load that page, but we can not show the frame, and that's a lot safer, because then the code will still be there, it just won't show up on the screen.
Got it.
All right, so now we go into parser.htm, and this is where it gets a little bit more thick with the code. So you can see that we've got a ton of scripts included in here. We've got JSON, which is just a library that turns objects into JavaScript object notation strings, and then turns the strings back into objects. So that's just basically a black box include. Then we've got jQuery also. We use some jQuery methods. That's just another black box included, black box of code included in there that we use some of the libraries. Config.js is your configuration file for your particular implementation, and that's included so that we know where your course root directory is and where your SCORM manifest is, what you've named your manifest, and all that stuff is set up in the config file. By default, the manifest is always called imsmanifest.xml, so that's what we have it configured by default. But if for some reason you have a different name, you can always configure that in your config file.
Right.
So we have to include config because we need some configuration information here so that we can load up the table of contents by parsing the manifest file, and then show the course by letting people click on the items in the table of contents. We also have browser detect, because we need to be able to detect if it's if you're running Chrome or Internet Explorer or what have you, for the switch case that we have in parser frameset. And then we have parse XML to object, which actually is another library that we use to parse the manifest file XML into an object. We then use the JSON library to turn that object into a JSON object, and then we traverse that object and make a menu using menu.js. And using createtablecontents.js. So createtablecontents.js is where we're going to go next, because createtablecontents is really what kind of drives the show once you have all the HTML pages loaded. So you have.
So just a quick question: is this going to be the where this is more than just generating a menu tree on the side?
Yeah, create table of contents generates the menu tree, plus it also figures out when you click a link what to do.
Got it. Okay.
So we first got the class, basically. It's called create table of contents, and inside of there are several methods. Init traverse, which is initialize the traversing of the XML file. So the file that's passed in is from over here, and it's the current active course. So the active course is figured out by taking the root directory, concatenating that with the manifest file, and then you get a relative path to the manifest, and you pass that in to initialize traverse, and we initialize the traversing of the XML tree. And so that's happening here. So we loop through that, and we use unordered list to make an unordered list of the things in the manifest file. And as we're making the list, we extract information out of the manifest file. We extract IDs from the manifest file, resources from the manifest file, all things that we're going to need to be able to launch content once a user sees the table of contents and is able to click on it. So this part, apply styles, is just applying the styles to the list. So that's really nothing that would ever need to be changed. Yeah, you're just looping and then putting the style sheet to the different levels. So really, if you wanted to change the look and feel, you would just change the style sheet. You wouldn't change this method. You would just change the style sheet that has menu level and then level X, and you could change the styles on each level. Then you have, this is for testing. There's a method called output plain, where you can just output everything that's in the manifest file in just a big long list, just a bulleted list, basically. And that's just, basically to make sure that your hierarchy is correct. And then, like I said, that's in there just for debugging.
Sure.
If we come down here, when we run the init traverse initializes the internal method called traverse, which would be this.traverse, pass in an object, a name, indentation, how far in we are, if we're at the first level or second level or third level, and the depth of that. And as we loop through, we pick up all the pieces of the manifest file. So we count how many number of organizations there are, and we only support a single organization, even though SCORM says you can support multiple organizations. We don't have a mechanism for doing that, and we've never run across a customer that had more than one organization in their manifest file. So for right now, we just have this alert. If someone comes up with a use case where we need to support it, then we'll just add the code in right there at that time. But so far, there's never been a need to support multiple manifests, so we just have an alert saying we don't support them, but if you need them, tell us, and we'll put them in.
Now, for the just up there for the where you're starting level or now let's say it's on 2. So what is let's say there's several level 2s in your
in the manifest?
Yeah, in your XML manifest. Then what does that mean? It just takes the first level 2? Or
no, what would happen if you had multiple level 2s, what it would do is you would have an object with the level, so you would be on level 2, and then the object would contain n number of links.
Right.
And so then they would be put all under the second level. So
I see. So you could hide the first level if you want to do that. So let's say if it just had 2, then you hide the first level, and it would just look like a flat or a straight.
Right. You could have the flat table of contents, or you could have nested. If you have items nested inside of items in your manifest file, then that's where you would get the multiple levels, and we would honor that in the hierarchy in the table of contents. Okay. And that's how we do it, by passing in the depth count, basically, and the indent. So the indent makes it look good on the screen, and the depth count keeps track of where we're at. So when someone clicks on the table of contents, we know at what level they're entering the content object or the content aggregation at.
Oh, okay, so that you can get back out.
So right, so A, so they can get back out, and B, so when we record the data, we know where to put it back to, because the depth is connected to the organization, or the identifier for the item that they launched.
Okay.
So we use the identifier of the item, which is tied to a SCO. We use that identifier to save all the JSON data, and the depth of that identifier is concatenated on there in case, for some reason, they've used multiple identifiers with the same name, which isn't supposed to be the case. They're supposed to be unique, but in case you don't make them unique, you can use the depth to make them unique, and then we're safe either way. You can't break our code by making your manifest wrong. Because 2 SCOs can't be in the same position. It's impossible.
Right. Okay. And so if I gave my SCO a unique name of 27,
then you would be fine.
Yeah.
But if you called them all 27, then
if I gave
27.1, 27.2, 27.3.
Right. Okay, and that's why it does it. It's the dot. It's the dot level. So
yeah, it's actually underscore, but
okay.
It just makes them unique so that you can't break it if you don't understand exactly how a manifest is supposed to be made.
Okay.
So anyway, we go through there, and then we make an array of the things that we're looking for in the manifest file. And this object is then used later on to say, hey, if we find a title or if we find an identifier, if we find an identifier ref or is visible, any of the other things listed in here, then we need to save them along with that object that they came from, so that when the user launches that object, which in this case would be a SCO, that the SCO gets all that information, because we have to send all that information to a SCO in the runtime environment. Otherwise, it's not going to have all of its data that it needs, like the mastery score, time limit, and all those prerequisites. If it has any of those things, it needs to receive them so it can do what it needs to do with them. So we make this array, which I just called the items we're looking for, because those are the items that we're looking for. It's pretty pretty straightforward. So then we go looking for the items. And so if we find organization, if we find item, and it just says, okay, well, if we found the item, then the other now change the items we're looking for to this, because you can nest different things inside of different things. So like if we found a title, well, then we can't be looking for another title yet, because titles can't be inside of titles. So every time we find something, then we change what we're looking for on the next loop. And so then if we find any of the things we're looking for, then the list may stay the same, if they're siblings of each other that we're looking for, or the list may change if they're children of other things that we were looking for. So, like for instance, if we're looking for item, then and we find item, then the next loop, well, we're looking for either title or any of the ADLCP items, or any of the other ADLCP data elements. And then if we find one of those, then we're looking for item again, or we're looking for a title.
Got it. Okay.
So then it just keeps switching back and forth based on how the manifest is written. And we did it like that because some people put stuff out of order, in the sense that like they'll put the title or they'll put all the ADLCP items and then the title and then an item and then a title and so we just said, well, instead of trying to force the manifest to be in the order that it's prescribed by the SCORM model, we'll just say, okay, well, if you open an item tag, then until you close it, we're going to be looking for these things inside of it, not in any particular order. So order doesn't matter, even though technically it's supposed to matter. We made it so that it doesn't matter because it was breaking stuff when we forced the order, because a lot of people weren't putting stuff in the right order. And I shouldn't say a lot of people. Most people weren't making the courses by hand. A lot of tools didn't export it in the right order. So, whatever. That's fine.
So
we
it
just made
cuts
it
down massively on support.
Yeah, well, yeah, exactly. It just cuts down on the support we have to deal with. We just said, okay, fine, order doesn't matter then. I don't care. So when we come to a point where we have an identifier, that means that we have something that is launchable. So then we create a string, which is going to be the link in the table of contents, and it holds the identifier ref attribute as well as the identifier attribute and the name child. In this case, that variable holds the name of the activity. So if we look at the table of contents for SSLA tryout, I have to get through these. So if we look at this here, what you're seeing on the screen is child, that variable, which is way over here now. So this variable child is SSLA tryout, and if I mouse over it, if you look here at the bottom of the screen where the scroll bar is.
Mm-hmm.
So watch there. When I mouse over it, you'll see how it says create TOC articulate res SSLA try, and it will say SSLA try out. So that's the identifier, and that's the identifier ref. So it's basically, when you click on this, it's looking up in the parsed manifest, in that JSON object that we end up with. It looks up what is the identifier and what are we supposed to be launching. So the identifier is used, which is the first part of this lookup by href. The identifier is used to as the key in the key value pair that we send back to the server that has the JSON data for that SCO.
Right.
So the key would be articulate underscore presenter underscore res underscore whatever level that is. And the value would be all of the data that was originally created by the user's experience in this SCO. That would be sent to your server via AJAX. And so that's where we get it from. We get it from when they click on that link, it's now in play, basically. So inside the manifest file, if we go into SSLA tryout and open that manifest file up, you'll see that it's right here. Articulate presenter res. If we mouse over that, you look at the bottom of the screen, articulate presenter res. Same name. So you don't have to pass anything in, and all of this information, mastery score is visible. All of those are the things that we were getting in our list of, is visible, mastery score, all the things that we need to collect. So when we click this link, this SCO will know about all of that. So we pull that out of the manifest file, and then we also ask your server, hey, do you have any data about this SCO with the ID of articulate presenter res? And if your server says, no, I don't, then it just returns either a null value or an empty JSON string or whatever. And we're like,
you use what you have in the manifest.
Yeah, and so then we're like, okay, well, we use what's in the manifest plus the default values, which are in, if we go back up to player 1.2, they're in cmidb.js. And you'll see, if we scroll down to about the middle of the page here, you can see if you don't give us nothing, if you give us something, then we're going to parse it using the JSON, the library, and we'll parse it into an object called this.localData. And if you don't send us anything that's useful, or you send us something that's corrupted or junk, then we're going to just use the defaults, which are these. And then here is, in this method, we pass in all of the query string variables that you send us, like student ID and student name, and then everything we got from the manifest file, which was here. And so we create this object, and this object is basically our little runtime database, and we dump this object, turn it into JSON, and dump it into your database every time you call, the course calls commit, or every time you call set value. And if our adapter is too chatty on your server, it's making too many requests, then you can go into the config file and tell it only send data when you call a commit, or only send data when you call set value, or some other, more restricted way of sending data, so you don't get so many hits on your server. All right, so we go back to here, and we were talking about, the create table content. So we made the link. I showed you that this child was connected to this link right here, and that if we mouse over it, we see the information that's contained in these variables. You know, create table of contents instance lookup by href. And so that lookup by href means basically exactly what it says. We're looking for, we're pulling the href that was in the manifest file, and then, I'm sorry, we're pulling the identifier that was in the manifest file and getting the href from that. So if we open up the manifest file, we're pulling this, and we're getting this.
Okay.
And we say concatenate your course directory, whatever you sent us in the query string, concatenate this course directory with this by way of lookup href by ref, and then you get a launched course. So that's how we actually find the SCO to launch, by using the manifest file. So if we go down to the lookup by href method, then you can see that we basically just, this is where we actually look it up. We say manifest resources resource, and then get the resource inside of there. Once you have the resource, then we need to check and see what version of SCORM it is, and then we know what player to launch that resource into. So we get the resource, let's say in this case it's resource articulate presenter res, and the href is index_lms.html, where, well, at this point right here, we have a handle to all of that information. Now what we do is we say, okay, well, what is the schema version? Because the schema version tells us what player we're going to use to launch this thing, this file that we just found in your manifest. So the schema version is pulled from metadata schema version, which is a required data model array, a required node that has to be in the manifest file, and it has to be in the manifest node. It has to be a child of that. It could be underneath all this LOM stuff. All this LOM stuff could be not even there, but it has to be in the child of manifest. So we get
so what is it, LOM? Sorry, what does that stand for?
Learning object metadata.
Okay.
So this is just the metadata for this course, which doesn't necessarily need to be there, but you still have metadata in schema version.
Right.
This is all that the adapter is looking for. But I think this was exported from Articulate. So Articulate just put all this extra metadata in there, which is cool. It's fine, whatever. But we grab the schema version and we see it's 1.2. So we go over here. All right, 1.2. Okay, so we need to load this player. That's what we know from that. And if it is any of these, then we load the SCORM 2004 player. And if it's any of these, which is nothing, or 1.1 or 1.0, then it's too old. We don't support it.
Yes, we have very consistent naming convention for the 2004.
Well, this was SCORM 2004 second edition, and then third edition, and then fourth edition. So all the editions are supported by the same player. So that's why we have the fall-through cases. So then we've got the file that needs to be launched, which is path, and then we've got where to launch it, at this point. So everything's happy. Then we concatenate all of the things we know from the manifest file into launch string, and then the launch string is what's actually sent over to the adapter.
Right.
Because it needs to know what data from LMS was, what time limit was, what's the credit, if they're taking it for credit or no credit, which is something you can set up in your LMS. It's a read-only variable in SCORM. The student name, the SCO ID, the path to the actual SCO, all that stuff is pertinent to the SCORM player, the adapter. If it doesn't have any of this information is missing, then it won't have anything to play, especially if you don't have a path or an ID. So those are really the two most important things. Everything else could technically be an empty string. Shouldn't be, but it could be, and the course would still run. So then we just set up whether it's launching a new window or launching a frame set. That's all this code right here. It just says how are we going to launch it. And then it's launched, and it ends up looking like this. So when you click on here, then all the code we just watched runs. This first alert comes up because we just asked a server that doesn't exist, hey, do you have any data for this course? And it returned an error saying, hey, there's no transport, meaning an AJAX method was just called to request some data from somewhere it doesn't exist. Anyway, it loads the course, and it said, well, we didn't get any data back, so either there's no server there or it had nothing to tell us. So we'll load the course with the defaults. And so the course still runs even if there's no backend, because the CMI_db.js file is still collecting all the data. It's just not going to send it anywhere. So when you call set value or when you call commit, it's just going to say, oh, AJAX failed, transport, no transport. Okay, forget it. I can't send it anywhere. So that being the case, you could technically also, instead of sending the data to a server, you could send it to a Flash shared object, or you could send it to like a data store in the browser, like the HTML local store, so that you could have a local run version of this as well. It doesn't necessarily need a database. It just needs somewhere to store a JSON string. So in my local edition, I run it on WAMP, which has a database, but so that would be like an LMS version, and then this that we're running right now would be like a local install where you would store it to some maybe a Flash shared object or a cookie or something like that, just for a local installation.
Flash shared objects, what seems that is basically something that when Flash is in your browser, then does it say that to it saves it to sort of a Flash cookie file, or?
Yeah, a Flash shared object is basically the equivalent of a browser cookie. Except that in a browser cookie you have 4,096 characters, I believe, of information to share or to save, whereas a Flash cookie or a Flash shared object, I'm sorry, you can have unlimited. You can set it to unlimited. I think by default it's set to 1 meg, but it can be upped to unlimited. So if you have a whole lot of SCORM data and Flash is an option, then you can store data there if you're running it from a CD or if you're running a local version. If you're running on an LMS, all this is a moot point. You're storing it in a database.
Sure.
But I just like to bring up that point because some people do use it as a CD-ROM version, and they also have an installation on their LMS, which is perfectly fine. You can do that if you want. There's no problem with that. It all runs client-side anyway. So, all right. So let's now get into the nitty-gritty of how the course actually sends data to the adapter and how that data gets to your server. Because so far we've talked about how to get the course into the browser, basically. But once the course is in the browser, then it's going to start sending all kinds of data to the API, the SCORM API. And so we have to create the SCORM API, and we have to put that API in the DOM somewhere in the browser, and we have to allow the course to find it, and then we have to expose all the methods that the course is going to use to send it data, and then we have to implement all the error checking and data, basically just data maintenance logic that the course expects based on the SCORM specification. And so inside of the SSLA folder, you'll find two child folders. One of them is SCORM Player 1.2, and one of them is Player 1.2, and the other one was Player 2004. They both have an API.js and a CMI_DB.js.
Mm-hmm.
All right.
Are those files identical or are they different?
No, they're totally different. One is supporting the 2004 standard. The other one is supporting the 1.2 standard.
Okay.
So I'm just going to take a look at the 1.2. That's what most people use when they're using this from us. So if I scroll down, you start to see that there is a class created in here called SCORM 1.2 API. That class gets instantiated into an object called API. Just happens to be that the course is looking for an object called API.
Okay.
All right, well, API.js is included inside of the parser .htm, and so when all that loads after the manifest has been parsed, then the course has access to the API object.
Okay. So the API object is something in memory that you create based on either 1.2 or the 2004. So it's an object in memory, and then the course in memory looks for the API object, and if it finds it, then it starts talking to that object. Okay.
Yep. So for right now, in this particular file, we have this method called SCORM 1.2 API, and in for SCORM 2004, we just call it SCORM 2004 API as our class. And then if I search for these are all the methods inside there. They're required by SCORM. Let me see. Okay. All right. So if I do a search for that, you'll see all the methods that we have. So we'll go through them one by one. The first one is LMS initialize. So we know that any SCORM course has to call initialize, right? So we're going to get an empty string sent into this method from the course at some time. And then we set a Boolean variable is initialized, gets set to true. If everything goes right, we set it to true. And also, if everything goes right, then we get oscormdata.data, which is it's all the data from the manifest file and all the data from your server or whatever data store you're using. And then we send that value into CMIDB, and then we call a method called call restore, and it restores that data or restores the default data, which is what I had showed earlier right here. Right, so it either does this, takes the data, and just whatever data you sent us, it turns it back into an object so we can continue to use it from the last session. Or if it's your first session or the data, you just didn't send us anything from the data source, then we start with the defaults. So that kicks everything off. That actually initializes it. This is where calling initialization actually does something.
Okay. The two FSO, what does FSO stand for?
Oh, the FSO stands for Flash Shared Object.
Okay.
Because originally when the code was developed, we developed it locally, got it all working, and then wrote the AJAX to post all the data to a server database.
That's just basically the I see. So and basically it's going to turn into the API object, right?
Right, exactly. We just have that variable name in there from when we originally created it back in 2000, and it was for a CD-ROM version, and then we continue to update it to where it worked, for server enterprise stuff, but some of the variables still show, the original implementation. And that's one of the variables that, harkens back to the original implementation. So anyway, we store the data in that variable, and then we then we send it in as a parameter to call restore. Call restore either actually restores the data if there's any data in there, or if there's no data in there, it brings back the default data. And then we have this instance of our little mini database, which we call this.local store, this.local data. This is our little, what I'm going to call mini database in the DOM, which is just an object of all the data model elements for SCORM that could possibly be set.
Okay.
And so then, as we'll get to finish in a minute, so then as you start setting data from the course into this adapter, then it starts running things like check and make sure the data model element's valid. Can I actually write to this data model element? Is the value you're trying to send me a valid value? If it is, then okay, we're good. If it's data that we can set, then we go ahead and call set value, and that sets the data into this.local data.
Mm-hmm.
And if it's something that we can't set for some reason, then we return false.
Okay.
And if we set the data, then the data is being set only into CMIDB. It hasn't necessarily gone to your LMS yet. It depends on the configuration you have in your configuration file. But since we don't know if it's gone to the LMS yet or not, we set the flag is dirty equal to true. So we know that we've updated the data, and we have new data that needs to get in to your database before this session closes. Otherwise, the student's going to be missing some data when they come back.
Got it. Okay.
So that's what that flag is for. All right, so we were setting values here. So we set the value, and if the value can be set, then it goes to set value, and we say that the data is dirty. So let's find set value. Okay, so set value, if you have the debugger on, writes a debug log saying you just tried to set this.
Mm-hmm.
And then it calls call set value on the CMIDB instance, which is in here. Call set value is up a little bit further. Call set value. And so setting a value is not just sending it to the database. You have to check and make sure that the time is, even if the time is of the proper time stamp, you have to convert it a little bit more so that it will go into the JSON object and then make it into the database. Also, we have to check for objectives. If you're setting an objective, then we need to make sure that the JSON object receives the objectives appropriately, and so we do this little check here. Interactions is the same thing. We have to check and see if you're using interaction type of true false, then your answer is either T or F, and that we store it properly in the JSON object, so when we get it back, we'll have all the correct data, and when we send it to you, you can parse it, traverse the interactions and not have them all just like interaction 1 and then its ID, and then interaction 2 and then its ID, and then interaction 1 again and its its result, and then we don't want to send them to you all out of order, because then when you traverse it, it's going to be all messed up. So we put it, make sure all the interactions were sent in order, and if they weren't, we put them all back in order and then store it.
I can create a dictionary out of that, which is what I do at my end, but I get it.
Right, exactly. And then in a .NET type of situation, you would get this object,
Mm-hmm.
which you would get this object as a JSON string, which would contain an entry for interactions, and you could create a dictionary out of the data that you receive, and then you can just search that dictionary for whatever you're looking for, the score, the interactions, the objectives, the lesson status, whatever it may be.
Okay.
So this goes on and on just because of all the different things, responses and patterns and different things you have to do with objectives. With objectives and with interactions. So that's basically just housekeeping, and then your data gets set, which is this .set local data. Like, it'll be up at the top. This .set local data just basically puts it into the local data store at that point. So we called the set from the set. The course calls LMS set value. Then the API checks to make sure that set value is a valid set value. If it is, the name value pairs are legitimate and they're legal for SCORM. Then API calls set value. The set value inside of API calls cmidb.call set value, which does the rest of the work to clean up the time and clean up the objectives and interactions, which I just showed. And then if all that comes out happy, then we call this ._set local data, which the local data is what you actually end up getting sent back to your server when a commit is called.
Okay.
And so that is just a basic wrapper function that says put it into local data and return true. And if you can't do that for some reason, then return false and print to the debug report that, there was an error, something happened. I wasn't able to put the value that you asked me to into the local data, so you're not going to get it in your server.
So that first line, that first line there then is basically saying clean up the local data.
No, this right here, I'm just saying the value that the person sent, the value that the course sent in. Let's say it was cmi.core.score.raw set to 80. So then the value would be string value of 80, and the name would be cmi.core.score.raw. So this is the end result of everything's finally cool. We can put it in. We can put it into storage.
Okay.
So it just takes the name value pair of the LMS set value that came from the course and just puts it into this local data. So technically, if you didn't want to do any error checking, if you didn't care about whether you get bad data or good data, you could just cut to the chase and call that. But if you did that, then your data would be all messed up when you received it on the server, and when the course got it back, it would be totally useless.
Okay.
So, there's a lot of work that has to be done before we get to this point, but this is where we're trying to get to. This is, we're happy, the data's dirty, we've got everything in there that we need to have in there.
Okay.
All right, so then the next method that makes sense to talk about would be get value. LMS get value is the method that you call, send in one parameter, which is the data model element that you want to get the value for, right?
Okay.
So using our previous example, if we set the score to 80 and I want to get the score, then in my course I would say LMS get value, parameter being double quote cmi.core.score.raw double quote close parens, that's the parameter. Well, that would end up in here, And then if you have debugging on, it'll say, hey, we're in this method and we're getting cmi.core.score.raw from the LMS. That's where we're at right now. So we say if it's initialized, because we can't get anything, we're not allowed to get anything from the LMS if it's not initialized. And the only time this is set to false is either if initialize failed to begin with or if finish is called.
Okay.
So if finish is called, then you just close the session, and if you try to continue to do something, then we're going to give you an error 301 saying you can't set any data because you have no session anymore. But we're going to assume that you didn't do any of that. We're going to assume that you did everything correctly. So then the next thing we do is we check error handling, make sure that there are no errors and that all of your data is good, which is the next check. You know, we make sure that you're actually setting a valid data model element. And we check to see if you're using .children that that you get the right children back. So like if you ask for cmi.core.score.children, then you should receive raw, min, and max. And so this method goes and picks that up from an object that contains all that static information based on the SCORM spec. And so you would get that value. Otherwise, it's going to call get value, which is just the reverse of set value. Get value goes into CMIDB, opens up this .local underscore data, and looks for this key inside of that object, and then returns whatever was in there.
Okay.
So it doesn't go to your database, it goes to the local store.
So this is, for example, this is what your course, who would be getting, like let's say you wanted to start on slide 3 or something. So
right, so then what would happen is the course would call get value, the data underscore model underscore element that would be passed in would either be cmi.core.lesson underscore location or cmi.suspend underscore data. And then if there was something sent in from your database regarding that data model element, it would be in CMIDB, and so when we do get value, it would return that value. If we hadn't received anything from your database when we kicked off this session, then we would return empty string and your course would start at the beginning.
Okay. So this is, now this call is made both from, made by the, sorry, it is made by the SSLA both to check, to send, so that it can send data to the course, as well as, I suppose, we never use it to just sort of get bits and pieces of data. They would never call it to get bits and pieces of data to send back to the LMS with it.
Right. This is not, get value does not ever connect to the LMS in any way. Or it doesn't ever connect to the data source in any way, the persistent data source. It only connects to the local data source.
Right. Okay.
And get value, SCORM is basically set up so that the course always does the transactions. So the adapter is never going to send something to the course that it didn't ask for. So everything has to go through get value. So the course is always going to initiate the communication and say, hey, go get me this. And then the adapter's like, yes, sir. I will first check and make sure that what you're asking for is legitimate. And if you're asking for something that's legitimate, I'll be more than happy to go get it for you.
Got it.
And so that's
it's
what
really
happens here.
helpful now for me to think of that just in terms of the persistent data source and the SSLA data source, which is, and basically it's doing checking back and forth to make sure that the data is good before sending it on to anybody.
Right, exactly. So it doesn't, you have, basically you have a filter which is called API.js.
Right.
And that filter has all the SCORM rules built into it, whether it's the SCORM 1.2 or the SCORM 2004 version.
Right.
Has all the rules built into it. So the course tries to push data through the filter or pull data from the other side through the filter.
Right.
And if the filter says, no, that's not the right data or that's not good data, it'll either fix the data or it'll return false to the course and say, hey, you're asking for something that doesn't exist, or you just tried to set something in the wrong order, or XYZ, whatever SCORM prescribes as the failure code is supposed to be. If everything goes well, which 99.99% of the times it does, because by the time the course gets to the LMS, it's been vetted and it usually is working properly. So let's assume that everything works fine. So then that filter is in place just for the off case that something is not done properly. So it goes through the filter, which is API.js. The data goes through the filter, and it hits set value. Well, set value sets it into the CMIDB, which is the local data store. Right. And then if you have in your configuration file set data to my persistent data store, whenever I set data to a local data store, basically a syncing mechanism, if you set that up in the config file, then the data store will be turned into a JSON object and synced with your database every time the variable is set to dirty.
Okay.
So every time the data is dirty in the local store, it'll be persisted if you have that set up in the config file. If you have the config file set up only give me data when the course calls commit, then the CMIDB and API.js will record all of the isDirty transactions, and then once the course calls commit, it will dump the latest object that exists in the local store into the persistent store at that time.
Now, the course would call commit when? And or, I mean, I suppose it varies from vendor to vendor.
Well,
Is it, or?
this is where kind of the rub comes in, and that's why we put the configuration options in. Because some courses don't ever call commit.
Okay.
So that means that you could technically set up the configuration file where you say, oh, only send data on commit, but your course never calls commit. So then you would say, uh-oh, I'm never going to get the data.
Right.
Well, that's not true. Because if we go into LMS finish, then
it does call commit in there.
You look down here, and it should, yeah, it does an LMS commit as the last thing it does before it says it's not initialized anymore.
Right.
So even if your course never calls commit, this calls commit just, and it basically spoofs the API adapter into thinking that your LMS, that your course did call commit.
Right.
So that's kind of like a, clean up and exactly what it says, clean up and send all the data to the LMS in case the SCO never calls commit.
Right. So the minimum it can do is at the end of every session.
So at the minimum, if you call finish, then you'll get the data. Now we've had courses that don't call finish and don't call commit either, or courses that there's no exit button, so people just hit the browser X at the top, they just close the window out and there's no handling of anything. So what we do is say, well, you need to go in your config file and set it to send the data on every set value. So then every time the student makes a move in the course, the data gets dirty in the adapter, the data gets updated in your server. Now obviously that increases the chatter between the adapter and the server, but it also guarantees that you have everything that happened between the course and the adapter if there's a failure case, or if they just close out of the browser incorrectly or close out of your course incorrectly, you don't lose any data. it's probably a good time to take a look at the config file since we've referred to it so much. Since we don't really know what's going to happen, if you open up the config file and you scroll down to probably about halfway in. Oh, here we go. Save data on set value, save data on commit.
Right, okay.
And so it's basically what the comment says. Do you want the adapter to send data to your server every time set value is called by the course?
Which could be true more often than commit.
This will give you the most sets to your persistent data source.
Okay.
This will give you the least, but they won't necessarily give you any different data.
Right.
This will save you from catastrophic failure, but it may also give your server so much traffic that it'll be like a denial of service attack.
Right. Okay. Okay.
Not that bad, but I mean, you get my point. That it could be quite a lot. So we have in our development build, we also have the idea of queuing, where you could do something that's kind of different than both of these, which you would say, okay, well, I don't care about set value and I don't care about commit value either. I want to set up a queue and I want to put a timer in the adapter. And I want to say every 1 minute, I want the adapter to send me the queue that it has recorded.
Which would be the latest item on the queue.
Right, exactly. It would be it would basically pop the last item from the queue.
Okay.
And so that's another option that we're toying with as well, because then you can kind of control it to say, well, send it every minute, send it every 10 minutes, send it every 30 minutes, send it on an event, or every 10 minutes, whichever happens first, or some kind of combination that gets enough data to your server where you're protected from catastrophic failure, but not so much that you're going to have issues with transactions in your database.
Right. Right. Almost like a transaction on a single server, basically.
Right, exactly. Yeah, we're trying to get to a point where you have a happy medium. Right. You're willing to lose a little to get a little, or you're willing to use a lot of bandwidth to have no issues at all. It really depends on your setup and how and what data you care about too. In the transaction case, in the queuing case, we could say also, hey, every time a score comes over, hey, you got to dump it, but only send me the score. But interactions, you can send them all at the end because I don't really care if I lose them or not. So queuing and then being able to pop from that queue specific data model elements and say, these are the ones I really need saved every 10 seconds. I just cannot lose these.
Right.
So it's a lot of transactions, but a little tiny bit of data, and then a big string of data at the end. So that's also an option that we're toying with as well.
Okay.
So just ways of kind of meeting the needs of many different groups that may not have the server capacity or people to manage transactions on the server side, and et cetera, et cetera. So we'll try to do our best. We added timestamps so that since these transactions are asynchronous, you can use the timestamps to put them back in order. We'll use queuing so that if you are having issue with the timestamps, you can just catch the queue, and the queue puts everything back in order, and you can pick from the queue what you want to actually get. So a bunch of things just in kind of data manipulation. You can choose what you want. You don't have to take everything. Along just kind of finishing up with this data storage part of the configuration file, when you're deploying onto a server, obviously this needs to say server. We're not going to use anything else other than server. Ajax type post is going to be the best unless for some reason your server doesn't support post, then you're going to use get. But post is going to be the way to go unless you just can't do it. And then the set data URL and the get data URL are the endpoints that you want the data from cmidb.js, this .local underscore data, that object will be turned into a JSON string and it'll be sent to this address. It'll be the address to the web service that then has access to your database, your persistent data store. So a lot of folks, they'll make a copy, of this and do like that, and then, have one like that says localhost like I have here, and then when they want to go live, they'll comment that out and say, like JCA, jcasolutions.com or something, and that's their live version.
Yes, and it's always really important to make sure that when you're
right, when you deploy it, you need to make sure you've deployed it with the right URL, and you know that it's in dev or it's in production. So those are the endpoints that the data is going to go to, which is the set one. And then if we need to get any data from the persistent store, we're going to use the second one, which is get data. So they could technically be the same. You could both call them just do data or something like that.
In my case, I think they are, and I just do an if, or I think that's sort of the case.
Yeah, and if you get a value without a name, then we're trying to set something, and if you get a value and a name, then we know. I'm sorry, if you get a value and a name, we're trying to set something. If you just get a value, you're trying to get something. Or a lot of people will also do something like this, like and then they know they know that it's a set or a get, but it all goes to the same page. So whatever, it doesn't really matter. It's however you want to set it up. And there's 4 variables that are sent to this endpoint. One is called TOC data, which is named here, so you can change the name to whatever you want. TOC data contains everything that you see in the table of contents over here. So it's the table of contents data. It's what color that ball is. It's if this what the ID for this link is. It's whether it's completed or incomplete or passed or failed. All that is going to be in TOC data. If you're not using the table of contents, then you just ignore the TOC data when it comes over. If you are using the table of contents, then you need to send that back to us so that we can put the table of contents back to the state it was last time the student was using the course. You'll also receive initialize and finish. Initialize will be either true or false. The name will be initialized and the value will either be true or false. And then you'll receive finish, which the name will be finish and the value will either be true or false, and that tells you when the session begins and when the session ends, or I'm sorry, when the attempt begins and the attempt ends, so you can track attempts on your server if you would like to do that. And that's just the course told the adapter that it started, so we're going to tell you that it started, and the course told the adapter that it finished, so we're going to tell you that it finished. And then the last thing that we send over is the SCO ID, which in this case we get the SCO ID from the manifest file, and the SCO ID is articulate underscore presenter underscore res underscore 1 in this case, because there's only one level and it's at level 1. It's the first one in level 1. So that would be the ID, and then with that ID, the ID would be the name. With that ID would come the value of the JSON string, which contains everything inside everything that is in this dot local underscore data. So we pair this dot local underscore data as a JSON string with the identifier for the SCO that was running and send it over to you.
Okay.
So then when the course starts up again and the student clicks on this, we send you a request for this ID. Please look up articulate underscore presenter underscore res in your database for this student, for this course, and give us the JSON data that was with that was associated with that record so that we can put it back in this course and send the student back to where they left off.
Right.
And there's the magic.